Hi everyone, welcome or welcome back. I am Thomas Willingham and I'm here with Christopher Chapman.
What's up?
Say hi, Christopher.
Hi.
Okay. We are here, networking fundamentals. Oh, bam, I lost my Vanna whiteness. Networking fundamentals, and we're here to talk about defining network infrastructure and security.
Yep.
The objectives, so our skills and concepts that we will learn, understanding networks outside of the LAN, local area network, and understand security devices and zones. So, let's talk about the internet. Amazingly enough, the internet is a worldwide system of connected computer network devices that connect to the internet, use the TCP/IP protocol suite. The internet contains a lot of information, resources, and services, including World Wide Web, servers hosting content. Now, some people use internet and World Wide Web interchangeably. The internet is the overall infrastructure. The World Wide Web is a service provided on the internet.
Correct. I was happy on this one to include the very descriptive diagram. Very helpful.
Well, I mean, honestly, that is a standard graphic.
It is.
So when you see cloud, you typically think internet, unless you're talking about cloud infrastructure.
Unless you're talking about the cloud. So we've gone so long learning internet as the cloud that now we're going to add cloud to it to make it more complicated. So.
Correct. Internet also has supporting infrastructure for email and connectivity for peer-to-peer networks. So we talked about the internet and World Wide Web being one of the services provided on the internet. It's a system of interlinked hypertext documents that can be accessed using a web browser. Interlinked hypertext documents can contain text, graphics, videos, a variety of content. Currently, we refer to the World Wide Web as World Wide Web 2.0. This refers to the social aspect of the web. So as it's become more social in nature with Facebook and Twitter and things of that nature, we've entered what we refer to as Web 2.0. It's a more interactive version of the web. Web 1.0 was more, I'm browsing the web, I'm looking at web pages. It was more static.
Like a broadcast.
Like a broadcast, exactly. Versus the Web 2.0 is a lot more dynamic. A lot more exchanging of ideas, the interactivity, and again, the social aspect of the web.
That is a giant one.
Intranet. So we have the internet, which is the global or external network. Intranet is a private computer network. So normally within a company, they will have an intranet or single website that an organization implements in order to share data with employees around the world. Typically, for intranet access, user authentication is necessary before a person can access the information. What this does is use of username and passwords, keeps the general public out, and allows people who need access to the information access, people who don't need information, it keeps them out. The extranet is basically the external facing or the external portion of a network. So the intranet is the internal facing, extranet is external facing. So it might be used for like partners or groups that work with the company but aren't necessarily in the company. User authentication would still be necessary, but again, the extranet is not open to the general public. So to access company data, there's a couple different methods. One is the intranet for internal employees. Second's the extranet for partners. And then the third is the web, web servers for the general public. So basically we have the different versions here. So there's partner, there's public, and there's remote users. So partner, they would use the extranet. Public, they might use web services. And remote users might use an intranet. VPN, Virtual Private Network, is a connection between two or more computers or devices that are not on the same private network that basically have a private conversation. In order to ensure that only the proper users and data sessions cross to a VPN device, data encapsulation and encryption is used. A tunnel is created from the client to the server through the LANs and WANs that are being used. So at that point, the LAN and WAN are just vehicles that this tunnel uses. Popular VPN protocols include PPTP, point-to-point tunneling protocol. This encapsulates point-to-point frames, PPP frames, into IP datagrams for transmission over an IP-based network. By default, the data is not encrypted in a PPTP session. So normally, or additionally, an encryption method such as MS-CHAP is used to encrypt data within the datagram. There's also LTTP or L2TP/IPsec. This is a combination of PPTP and layer 2 forwarding, L2F, put out by Cisco. Again, we're back into a whole bunch of acronyms here. The PPTP and layer 2 forwarding, L2TP, is used for the tunneling. IPsec is used to encrypt the data. So this is a little bit more secure than straight PPTP. Point-to-point tunneling protocol allows multi-protocol traffic to be encrypted and then encapsulated in an IP header sent across an IP network or a public network. They can be used for remote access and site-to-site VPN connections. It uses a TCP connection for tunnel management and a modified version of generic routing encapsulation, GRE, to encapsulate PPP frames. The payload of the encapsulated PPP frame can be encrypted, compressed, or both, but PPTP doesn't do this. You would need to use a different protocol to encapsulate that protocol. And then in the graphic, we see a example of what the frame might look like. So the IP header, the GRE header, and then the PPP frame. Again, if it's actually encrypted, it's encrypted using an additional protocol. That's the benefit of L2TP with IPsec, is it includes data encryption and encapsulation. So again, allows multi-protocol traffic to be encrypted and then sent over any medium that supports point-to-point datagram delivery. L2TP relies on IPsec in transport mode for encryption services. And encapsulation for the L2TP IPsec packet consists of two layers. The first layer is L2TP encapsulation, so the PPP frame is wrapped with an L2TP and UDP header, so that represents that top frame. And then the IPsec encapsulation, so the L2TP message is wrapped with an IPsec encapsulation security payload, ESP, header, and trailer, and an IPsec authentication trailer. So let me do this here really quick. So
while you're doing that, I'll inject a little note. These details we're doing for the advantage of people learning the information, learning how these technologies work, and especially in this case, what encapsulation is, taking the existing packet, wrapping it in some additional information. But this detail is probably beyond what you'll need, say, for the certification. It's probably beyond what you need really in implementing these technologies. You need to know a lot about the technologies, but you need to know more about the interfaces for implementing them, L2TP, PPTP, and IPsec, the components within Windows clients and servers to implement them, more so than the packets themselves. We figured it'd be good information anyways.
Plus, it's just plain fun. This is fun. So look, you're taking this packet right here that has an IP header, UDP header, L2TP header, the PPP header, and then the payload that at this point is not encrypted. You're adding the ESP header, the L2, oh no, that's already there. So you're adding the IPsec ESP header, the trailer, you're encrypting this payload, and then also adding an IPsec authorization trailer. So this is basically what the packet encapsulation and encryption looks like. You start up here with this packet, and then that gets encrypted and encapsulated in this packet here. This brings us to a demo, custom RAS configuration, show how a VPN connection would work. So let's go ahead and take a look at that. So that brings us to you.
It does.
Mr.
It does indeed.
Christopher.
I'm ready for this. So it was custom RS configuration. We actually talked about this in a previous module. I'm going to undo what I did before. I'm going to disable routing and remote access. And it's going to undo anything I've done to configure this server. And it shouldn't take too terribly long. There we go. All right, so let's close that. So we're back at Server Manager, Tools, Routing Remote Access. So it's here, it's clean, it's shut down, it's not set up for anything in particular. Configure and enable. Same wizard. What do we want to do with it? Now in this case, last time we set up a secure connection between two private networks. We don't quite want to do that this time. Custom configuration lets me choose exactly what I want. VPN access, LAN routing, and these are things that can implement the technologies we're talking about. So for now, that's good enough. We'll just use those. LAN routing, not important in this particular instance. VPN access is the one we're really going for. And we're ready to go. So it looks the same, but like I'd mentioned, some of the things are different. If I go to properties on the server, this first tab right here is different, IPv4 remote access server. And this is where I can configure the different components of that, that VPN connection. I can set up ports right here, right away, because it's a VPN. This server has all of these available connections for a VPN connection. SSTP being another protocol. If I scroll down through this list, we're going to get to PPTP. And if I continue scrolling down, we're going to get to IKEV2, which is an IPsec protocol. That is really all we're going to talk about. Again, we're not going to go into great detail. We don't have the ability to test this fully in a demo environment. There are other considerations if you're implementing VPNs that relate to firewalls and ports and the protocols you allow through your firewall. But that's about all we're going to cover. Now, on this particular server, I also mentioned as part of the demo, we're going to look at a VPN connection. I'm going to open Network and Sharing Center. We're going to get the default Network and Sharing Center screen eventually. And this looks pretty normal. Set up a new connection or network. Connect to the internet. In this case, we're not connecting to the internet, we're connecting to a VPN. We want to create a VPN connection. Click that. I can use my existing internet connection. I'm already connected to the internet, so I don't need the VPN for that. I can also dial directly, connect to a phone number. I vaguely remember this technology being in use at some point in the past. These days, we're probably just going to use our existing connection. Internet address, you can use names or IPs. I don't even know if this is a real domain name. I'm just doing it to create the connection. Once this is done, though, I create it, and all I'm doing is giving it that name. It creates it just fine. VPN connection right here. It won't connect to anything because I haven't configured it for an actual domain name. But the important part is that once it's configured, I can modify. I right-click, View Connection Settings, and I can modify all the information about what type of VPN connection it is. Security, type of VPN. I can tell it what it is. And then that will actually give me other options for further configuration down at the bottom. A lot of things just got grayed out. Authentication we're not using. Let's go with SSTP. I mean, all of these come with different advanced settings as well. Pre-shared keys versus certificates. We don't have the time nor this exam, the information we're giving you today, doesn't go into enough depth that we need to worry about the advanced settings on certificates versus pre-shared keys. The joy of PPTP and SSTP is it's essentially server-side, you set it up and you're good. You set it up on the server, you give users instructions on how to set it up or use group policy to deploy pre-existing connectoids, and they'll just connect. With L2TP or IPsec, you actually have to make some of these decisions. You've got to configure things on both the server side and the client side. But that's pretty much all I'm going to cover for VPNs. There are networking options. Past experience makes me want to go through more of these. I've done things with VPNs that I want to just, you need to go in here and you need to make sure that you're using the right settings. Use default gateway on remote network. This is a huge one. If you're at home and you're VPNing into work and you've got this box checked, everything you do on the internet's going through that VPN connection. It's not using your home internet connection for anything if you're connecting to Netflix to watch movies or any service. You're going to live.com or going to outlook.com to check your email. It's actually going to go through that external VPN connection if you've got this checked. So, little tidbits of information to know. That's pretty much it. That's about 4 layers down. So, luckily this is a video, so you can go back and look at it anytime you want.
Anytime you want to. And really quick, to go back to the phones where it said you're dialing into. Okay, I might be dating myself a little bit here, but back in the day, companies would have banks of modems that you would dial into that would allow you to access the network.
Yep.
So you would dial in from your modem directly to a company modem. And then once you were dialed in, you would go through the authentication system, go through the naming server, and then once you were connected, you'd be connected directly to the corporate network.
Yep. I was kind of fortunate. Modem banks are something I've heard about and never actually seen or worked with. They existed when I got into IT, but I personally have not had to manage them or work with them.
Yeah, they're
tons of fun.
Yeah, they're
easily configured and managed.
Oh yeah, they're great times. Great times. Because then not only do you have to configure modem interconnectivity to the server, but you have to configure telephone connection into the modem.
Well, and from what I remember of modems, modem connectivity to the server by itself is enough to explain why you don't have any hair. So you say modem banks, now I understand.
Modem banks. What can I say?
Now I get it.
Yep. Okay, so VPNs. Let's talk about firewalls. So we've talked about connecting to the servers. We've talked about connecting an intranet. We've talked about an extranet. We've talked about web access. But how do you keep people who don't need access to the data, how do you keep them out? If you're connected to the web, how do you keep your environment from basically just having complete access to the web? Before NAT became popular, any device that you gave an IP address to, it had to be a legitimate IP address and was accessible from the internet. So you would have client devices that were accessible from the internet directly. They decided that probably wasn't the best idea. So what they came up with, besides NAT, remember network address translation that allows addresses from one network to be translated into addresses for another network, firewalls. Basically, firewalls allow the filtering of traffic internally and externally. Traffic can be configured to be filtered externally. Maybe you don't want employees within your company or small office or home or whatever going to certain sites. So you might basically filter out certain sites. You may not want people looking up keywords. You may not want certain types of sessions going out. So you could use a firewall to disallow that outgoing. You can also use a firewall for incoming connections to disallow incoming connections. So firewalls basically protect networks from malicious attacks and direct connections from the internet. They're a very popular type of security device. And if we look back at the graphic here, we see this is just a graphic of we have two devices, a server and a client and a router and the internet. Probably not optimal configuration. What we want in there is we want a firewall. We want that, and normally this is represented by a brick wall in documentation. And one of the most commonly used type of security devices in an organization at the perimeter.
Yep. Well, perimeter is relative here in just a second.
Well, exactly. So now let's talk about security devices and zones. So security devices such as firewalls can be a main defense within a company's network, regardless of their LANs, WANs, intranets, or extranets. Perimeter networks are basically segregated areas of the network that aren't on the intranet and yet aren't on the internet. So it's a separated area. So if you look here at this network, let's kind of look at the graphic here. We see here's the internal network here. We see a firewall here. We see a router, servers, a router, and a firewall. So notice in here, there are two separate firewalls. So if we advance the graphic here, we notice that this area right here that's been blocked out is referred to as the perimeter network. Out here, we have public facing. So here's our partner, our public, our remote users. So when public and partner gain access to, say, web servers or email servers, they're here in the perimeter network. And then remote users who VPN might VPN in through the perimeter network and access the network, depending on how things are set up.
Yeah, there's a lot of options. Once you get into perimeter networks, there are lots and lots of options.
And there's different, there's the three-legged approach, there's the segregated approach, there's different ways to do this. And we don't typically use the terminology, but popular kind of terminology for a perimeter network, people might also hear DMZ or demilitarized zone.
Yep. One thing we don't cover in this that's really, really fun to do with setups like this is what's called a honeypot. You set up a server either in a perimeter network or even in front of the perimeter network, out where that firewall is to your public, partner, and remote user-facing services, that essentially doesn't have any company-critical information on it. It doesn't really service requests at all, but it has every available service turned on and lit up. So that anybody who's trying to maliciously attack your network, they're going to find this computer that's just sitting there waiting to be attacked, and it's going to keep them away from actual network resources that are servicing real requests. So honeypots are kind of fun.
Honeypots are interesting. You also can see what methods people are using to attack your networks, which will give you, which will allow you to be more proactive to your servers that you do want to protect. Okay, so firewalls and security zones, one method of creating a firewall or filtering out this content is packet filtering. So packet filtering inspects each packet that passes through the firewall and accepts it or rejects it based on a certain set of rules. This system has two different methods, one stateless and one stateful. Stateless packet inspection does not retain memory of the packets that have passed through the firewall. Stateless packet inspection maintain content text about active sessions. Okay, so the difference here is stateless basically works off a set of rules. Every incoming packet or outgoing packet is unique. I evaluate it on its own, and I basically accept or reject based on my set of rules. I don't worry about anything else. I receive a packet, again, incoming or outgoing. I receive this packet. Does this follow my set of rules, yes or no? If it does, I accept. If not, I reject. Next packet, totally unique packet. Stateful, on the other hand, remembers sessions. So as a client and a server on the internet initiate a connection or a session, the firewall kind of monitors that in a stateful manner. So during certain periods of the connection, so initially, I expect basically a greeting to happen between the two sessions, to initiate the session. During this session, I expect certain parameters to be followed, depending on what type of session it is. And then at the end of the session, I expect a decent disconnect. As the packets travel back and forth, I'm monitoring each packet per connection. So I've received this packet. I know what session this is associated to. This is for an email session all of a sudden this is a URL for hyperlink protocol. Is this acceptable within this conversation? Yes or no? If it's not acceptable, you throw it away. If it is acceptable, you accept it.
Yep.
NAT filtering, network address translation. Again, basic definition for NAT is a NAT allows address translation from one network to another to overcome the IPv4 address issue. This also has some security associated with it. What this does is it filters traffic according to ports, TCP or UDP. It can be done in 3 ways. Using basic endpoint connectivity, so basically, again, managing the session. Matching incoming traffic to the corresponding outbound IP address connection. So, hey, I know I sent out a request to www.microsoft.com, which has this address. I'm receiving a response back from that address. I look at it. Yes, this is what I want. I accept it. And if finally matching incoming traffic to the corresponding address and port. Okay, so we've talked about ports. So HTTP port is Christopher. You remember?
I'm going to let them think about it for a second.
Oh, good. And actually, there's HTTP and HTTPS.
Indeed, there are both.
Okay, so
HTTP is port 80.
Okay, and that's just for normal HTTP requests versus HTTPS. I got a little T excited there. Got too many T's in there. So TTPS is for what?
443.
443
is for secure web traffic.
For secure web traffic. So I have a web conversation going on for port 443. So port 443, or I'm sorry, port 80. I have a session going. I'm expecting a response back for this associated 80 session, port 80 session. So I'm not only managing the IP address, I'm managing the specific port that I'm talking to. Application level gateway, ALG, supports address and port translation and checks whether the type of application traffic is allowed. So again, a very simple example. I'm dealing with email. I see a URL. Is this allowed? Yes or no? It may be, hey, the URL is embedded in the email, so it's an okay thing. But what if I'm doing email traffic and all of a sudden a URL is sent through? That may not be accepted.
So, and in this case, we show this as kind of a device on its own. We show it as an application level gateway as a device. Typically, that functionality is built into other devices. A lot of the things we're talking about, firewalls, routers, application level gateways, regular gateways, tend to be functionally all built into one box. So you're going to have, for instance, the best example I can come up with is at home when you're connecting your internet connection to your network, they give you a router. That router does do routing. It also does application level gateway functionality to some degree. It also may have a firewall built into it that works at a stateful level. They're all going to be in one device. So
and most likely NAT. It has NAT
it's
also.
Absolutely going to be a NAT device, yeah. And even that can be configured. You can go into these devices and look at the firewall config and the NAT config and the port forwarding config. So they all exist, and they're all usually bundled into a single device. So when you see it in a course like this, when you see these terms and see these functionalities, think about they could be separate boxes, but they're usually a tab on a multi-tab interface in a single box.
So that goes as you're purchasing your devices, kind of read through and see what the functionality, features and functionality of your device are. Okay, so circuit level gateway. Circuit level gateway works at the session layer of the OSI model. OSI model, 7 layers. You want to stab at it, or shall I stab at it?
Oh, you just stab at it, because remember, this was the game we were playing.
Yeah, this was the game we were playing.
Module.
Okay, so first of all, I'm going to go through the acronym I like.
Okay.
So a priest saw 10 nuns doing push-ups.
Okay.
Really? You're going to monitor my acronym?
Absolutely.
Okay, so application, priest, presentation. a pre-SAW, session, transport, network,
closely.
data link, physical.
Awesome.
Bam!
Yep.
Last time I think I reversed physical and data link.
No, you got it. I think you ended up getting it.
I got it.
was
I
a
think
quick fix. Yeah, something.
I burbled it in my head.
It happens.
It
Again, evidence to how often we actually use the individual OSI layers in our day-to-day IT world.
Right. So the circuit level gateway works at the session layer of the OSI model when a TCP or UDP connection is established. Filtering inspects sessions rather than connections or packets. So now we're looking, a lot of this filtering or firewall is just done at different levels. Is it a port level? Is it an application level? Is it a session level? So what level does the filtering occur? And then a lot of firewalls, as Christopher mentioned, will have this type of filtering at many levels. A proxy server acts as an intermediary between a LAN and the internet. Proxy basically means go-between, acting as a mediator between a private and a public network. Proxy server evaluates requests from the clients. They meet certain criteria, forwards them to the appropriate server. Proxy server, again, kind of adds a bit of security in there because your client isn't dealing directly with the internet service. This proxy server is that kind of go-between.
Microsoft actually used to have a product called Microsoft Proxy Server 2.0.
Yes, yeah. And it also performed caching.
It did.
And the caching portion of the proxy server, the benefit of this is our company uses, okay, so Christopher and I are part of a company, okay, we actually are, this isn't a hypothetical situation.
Okay.
I was going to make it hypothetical, but it doesn't have to be. So Christopher and I are both part of Microsoft, and every day when he and I get in, we both have this website, www.microsoft.com/technet, that we both go to. So when I go to the website, let's say on a certain day I got in before Christopher, so I go in and I log into the website and I start accessing the website. A caching proxy buffers those web pages and buffers that information. So when Christopher comes out or comes in and goes to the web page, the proxy server doesn't go all the way to the internet anymore. The proxy server, when Christopher asks for the page, it looks internally and says, I have that page, here you go. So it speeds up access and allows basically for subsequent access of those pages to go much faster. An IP proxy secures a network by keeping machines behind it anonymous. It does this through the use of network address translation. So proxy being an intermediary device, network address translation being basically translating IP addresses from one network to another. Internet content filter, or simply a content filter, basically is applied to software at the application layer. Filters out various types of internet activities. Again, access to certain websites, email, instant messaging, and so on. So it allows certain rules to be created. Don't want access to maybe a BitTorrent site or a peer-to-peer site or other types of sites, or you don't want access to outside emails. You only want people able to access their own internal email. We don't need people accessing their external email. And again, the rules on your network may or may not be different. It's all dependent on the needs of your network. How secure does your network need to be? And remember, networking security is kind of unique in that security is keeping people away from things. And networking is allowing people access to things. So they're kind of at odds. So networking security is kind of different, and let me kind of modify the definition for networking security. Networking security is ensuring that those that need access to data and resources have continued access, ensuring that those that aren't supposed to have access to data and resources don't have access. So there's actually two components to it. network intrusion and detection. So basically monitoring the network for malicious networking activities like port scans, denial of service attacks. Port scans are basically checking different ports on your server to see what's open.
Someone else checking different ports.
Someone else. Well, you might do a port scan on your own system.
That's true, for security reasons, yeah.
For security purposes, but allowing access to different ports, and then with different ports you can do different things. And certain ports being able to accept different types of information, somebody may be able to create executable that you could send to a port that could cause malicious things to happen.
Yep.
Denial of service attacks, basically sending too many requests to a server. The server is unable to fulfill all the requests and basically kind of throws its hands up and is like, I'm not sure what to do.
I'm out.
It's kind of like going to lunch with Christopher. When you go to lunch with Christopher and you're walking down the hallway, all these people run up to him and they're like, Christopher, we'd really like to have your autograph and we really need information from you. And it happens that there are so many people overwhelming him that he just doesn't know what to do. And it's kind of funny because he lays on the floor and kind of gets fetal and kind of twitches a little bit. So that is a possible example of a denial of service attack.
He wouldn't say anything to anyone ever.
It's a really good example, though.
I know. It's the life I live.
It is. That's what happens when you're famous. And people want information from you. So you need a better network intrusion detection system and prevention system.
I do indeed.
Maybe a little fly swatter, so as people run up to you, you can like swat them away.
Not a bad idea. I wonder if I could put IDS on it and just...
There you go. No to you. Puh.
That would work.
Just saying. So prevention systems, basically designed to inspect incoming traffic, take a look at it, based on the configuration of security policy, accepts or rejects. Now notice a lot of these systems, you keep hearing me use the same terminology, inspect, accept, reject. That's kind of the format for all of these systems. There's an inspection or review process. After the review, does it meet my criteria or not meet my criteria? If it meets, I accept. If it doesn't meet, I reject. Perimeter network. Again, a perimeter network is a small area of your network set aside that's not on the internet, it's not on the internet, it's segregated and kind of separated from the private network and from the internet. Perimeter network, again, some people may be familiar with the DMZ terminology.
Potentially, yeah.
Potentially. And it allows users outside a company to access specific resources or services located within this perimeter network region. When set up properly, users are blocked from gaining access to the company LAN, but they still have access to resources needed provided by the company. Perimeter network might house a switch with servers connected to it that offer web, email, and other types of services. Perimeter network configurations, we talked about this a little bit earlier. So we have back-to-back configuration and three-legged perimeter configuration. Back-to-back is basically a firewall on the internet, a firewall on the private network, and then the perimeter network in between it.
Absolutely.
A three-legged perimeter configuration is usually attached to a separate connection to the company firewall. The company firewall attaches to the private network, the internet, and the perimeter network.
Yep, it is possible. Ta-da!
Now I'm sad again.
One more time at a summary.
I'm sad again. We've talked about differentiating between internet, intranets, and extranets. We've talked a bit about firewalls, the review, accept, reject model, and the different levels that you can filter. We've talked about perimeter devices and zones, and the functionality of like proxy servers, internet content servers, and a perimeter network. And additional resources.
Well, this time, we're kind of closing this out. So books, Exam 98366, MTA Networking Fundamentals, Microsoft Official Academic Course. Great book to get if you want to augment what you're learning today. If you want to go another step further and get instructor-led with peers and potentially hands-on, 40366A Networking Fundamentals MTA Exam 98-366 is our instructor-led course. We have 3 other course packages that either augment or include this one as part of a package. And then when you're done, when you're feeling comfortable, when you've used this for a while, when you've gotten used to it, maybe broken a network or two in a test environment, it's time to get on to the certification exam 98-366, Networking Fundamentals, Microsoft Technology Associate.
And as I highlighted, I just threw it in here one more time, my remote desktop poster, because I'm really proud of it, and I love it.
Awesome.
So I highlighted it, because it's good stuff.
All right.
It's totally good stuff.
It actually is.
This, sadly enough, brings us to the end.
This is the conclusion.
For this course, Networking Fundamentals.
Yeah, we need some fireworks. We need some.
Yeah, for this session, there is no more.
That's all we
Fiend.
get. Nothing.
Elfine, yeah, like, where's the sad little clown that, like, because, yeah.
I didn't think of that. We do need that for the next one.
Yeah.
We'll have to arrange for a sad little clown to come in.
A sad
here.
little clown to
Just
come in
sit
and be
behind
like,
us.
oh, it's over.
It's a good idea.
Yeah.
Well, thanks for watching, though. We do appreciate it.
Thanks for watching. Great resources available. There's TechNet resources. There's Microsoft Learning. There's Microsoft Virtual Academy. Talked a bit about those on the previous slide.
Yep.
Don't be afraid to just dig in. Honestly, you're going to... Oh, and Channel 9 is another great resource.
It is.
As you go through these resources, initially you may be watching this stuff and be like, I don't understand a word they're saying. And you may not, and that's okay. Keep watching. Don't be afraid. Watch another video, and you're gonna find out that, I understand more now. And you're just gonna find that as you watch these videos, you're gonna get a greater understanding of stuff.
Yeah, it's hard to teach an entire industry in a linear fashion.
Yes.
And cover everything in the right order.
Well, and plus, different people have different interests, different areas that they want to go into. They may, because networking, there's tons of components to it.
That's true.
There's the physical infrastructure. There's managing servers. There's managing clients. There's security, day-to-day administration, email, web. I mean, there's a lot of different things that people could go into.
There are. So I'd stick with your idea then. Don't quit learning. At this point, watch another one. Watch this one again.
They could do that.
They can. It's a joy of video.
That is. Great. Well, thanks for stopping by,
Yep.
and we look forward to seeing you in the next video.